Hello, welcome to this video. This is a question 5 from the 2020 May-June series, and it's paper 2-2, as you can see on there. And this has been requested by Bodhidana. All right, and she's more than welcome, as anyone is, if you want to, if you want me to make videos on things. Obviously, it's an organic question. Before we do anything, let's have a quick look, see if we can mess around with it a little bit for fun. All right, let's start off with this orange color. This is the theme, obviously, this top thing, and this is ethanol. So from here to here, it's some sort of, we've added water, haven't we? That's a hydration. Then we've oxidized the primary alcohol to the aldehyde. So this is ethanol. All right, so there's some sort of oxidation going on there. So I'm going to show that like that. Then we've added a CN, haven't we? This is a CN group to this. So we've added a HCN, and we've got this thing called a cyanohydrin. I don't know the exact name of this one, but we'll figure it out later. This is called a cyanohydrin. And then we heat with the dilute acid, and hopefully when you heat or hydrolyze one of these, hydrolysis, this group here, the CN group, turns to a carboxylic acid. So we're going to get a hydroxy carboxylic acid here. Okay, now obviously I haven't done the question yet. I'm just messing around. And here, reaction 5, we've taken out an OH and we've replaced it with a Cl. I'd use PCl5 for that. Okay, so that's roughly, let's see how the question pans out after that. Complete the table to give the names of the reagents mechanisms in reactions 1 to 6. Now, even though you can't see what I'm doing here, I've got the answer scheme next to me, so I don't make a mistake. But I'm not going to use the answer scheme until I've guessed a little bit. Reaction 1, I'm going to call that's going to be an addition reaction, isn't it, as I've said. And if we're adding across a double bond, we're going to have, that's going to be electrophilic addition. Let me use a different pen. This one. So this is electrophilic addition. That's a nice, easy one to start with. What do we need there? Well, obviously we're adding water, so it's going to be steam, isn't it? We use a phosphoric acid catalyst, don't we? Oh, it says name. Okay, so I can't use any formula here, so that's me messing up, isn't it? So I'm going to change that to phosphoric acid catalyst. There you go. Catalyst, and these are normally in pellets. These are solid. And the temperature, well, it's quite hot. I've always thought of this as about 200 degrees C. All right. Reaction number 2. This is, they don't want the name of the mechanism here because it's not on our syllabus. But what would you use to oxidize a primary alcohol? I would use acidifieds. Acidified. Now you can use the purple stuff or the potassium dichromate, but we want the weaker one here because we don't want to oxidize all the way to a carboxylic acid. Okay, so I'm going to use acidified potassium dichromates. All right, and we distill this. We warm it, don't we? We heat it, heat, and distill off the aldehyde. Now, interestingly, we do not. Let me get a different color pen for this. So this one, you should all know, we do not reflux, because if we reflux this, it will go to the carboxylic acid, and we don't want that. We want to stop halfway through. Okay, so there you go. Hope that makes sense. Number 6. That's a big jump there. Number 6. Which one's number 6? Number 6. Reaction number 6. Where's number 6? Oh, there's number 6. I didn't see that, didn't I? Now this one. Whoopsie, I'm messing this up, aren't I? This one we're changing out Cl for an NH3, so we're going to use ammonia. All right. Now, the ammonia is going to be dissolved in ethanol, okay, in a sealed tube, because otherwise the ammonia will evaporate and we heat. All right, so that's going to be part of the question. What's the mechanism? Well, we're swapping out one thing for the other, so it's a substitution. Okay. And the NH3 will attack this carbon, and so it's going to be a nucleophilic substitution. And that makes sense. It attacks that carbon because it's going to be a little bit positive. So let me get down to here. And so the mechanism is, where are we? Nucleophilic substitution. And we want alcoholic ammonia in a sealed tube, and we also want heat. Okay, all right. And if it's in a sealed tube, it's under pressure, isn't it? Okay, so you could also say under pressure here, under pressure. But the sealed tube kind of takes care of that. Hope that makes sense. All right. So if I say anything that you don't understand, please just get in touch, and I'll do what I can. Now this looks like the mechanism they want. The next bit. It's not too long a question actually. I hope this is the one Body Banner wants. All right. So let's make this bigger. There we are. All right. In that reaction 3, the organic molecule reacts with HCN and a KCN catalyst. Complete the diagram to show the mechanism of the reaction occurring. Include all relevant dipoles, lone pairs, curly arrows, and nuances. Now, let's do this nicely. What colour am I going to use? Let me use a nice bright colour. Let me use red for this. Okay, first of all, this is going to be delta negative, delta positive. And there's going to have to be electrons on there. There's also electrons on the nitrogen, by the way, but we don't bother with those on this. Now, the first thing is these electrons are going to attack this partial positive, and these electrons are going to jump over there. All right, so we get this thing now. Okay, so that's what happens when I've done this. I'm going to call this step 1, and we get this step 2 thing. This thing here, intermediate. All right, now what happens here? Well, we've got to regenerate the cyanide ion, so something happens with this thing down here. Okay, so let's try and figure out what. Let's get rid of that arrow. That will confuse things. Now, first of all, I need electrons on here, and there's actually 2 lone pairs on there. Okay, now the CN part of the molecule is negative, and the hydrogen is positive. So what happens is these electrons come out here to capture the hydrogen, and these electrons go on to here to form my Cn minus. Okay, so that's what's going on here. I'm just checking the other scheme, make sure I'm right, and I'm exactly right there. Oh, apart from I've done more than them actually. I've given the partial charges on my HCN, which they didn't want. But there you go. I hope this makes sense. All what I've done there is worth 3 marks. Piece of cake. Okay, so what this is we started off with the cyanide ion, and we ended up with the cyanide ion. So we have regenerated it. So it is a catalyst, isn't it? Name the functional groups present in the product of reaction 3. Right, now this is called a nitrile. Okay, and this is called a secondary alcohol. Okay. All right, now I'm going to check the answer scheme. So do they want it like that? Yeah, they don't even want secondary, but I think you should know that it's a secondary alcohol. Draw the structure of the organic molecule W formed in reaction 4. Now it's this guy. I'm going to redraw this in a different color. Let's draw it in. I can't draw it in white, can I? Let me draw it in yellow. All right. Oh, that's not good at all, is it? Let me do orange. So we have CH3, this guy, and this. There's a nitrile and my OH. Now, these things, what can we do with these? Well, this group here, if you react it with an aqueous acid, okay, and you heat, it will give us hydrolysis. Okay, and it will turn into, as I said above, it will turn into a carboxylic acid. So that's all I've got to do. I've just got to show this. Okay, so CH3, CH, OH, nothing's happened there. But this bit's turned into a carboxylic acid. So there you go, that's that. Now I'm looking at the answer scheme, and it has the skeletal formula. It doesn't ask for a skeletal formula, so this is perfectly fine what I've done here. But let's draw the skeletal formula anyway. Okay, so I'm going to draw 3 in a row, 3 carbons in a row, because that's how many it is. And 1, 2, 3, that's 3 in a row. Off the middle one is going to be a carboxylic acid, so I'm going to draw that. That's a carboxylic acid off the middle one. And off there, we've always got, oh, is that enough? Yeah, that's right. There's an OH there. So that's it. 3 carbons and that. Now these guys, let me do a bit of naming here. This guy is called, it's 3 in a row. So it's called propane nitrile. Okay, there, that's 3 in a row. So this is called propane nitrile. There's something off of number 2. It's a hydroxy. So this is called 2 hydroxy hydroxy, propane nitrile, and these things are known as cyanohydrins. Okay, interesting name, but that's what they're called. All right, and that's 2-hydroxypropane nitrile. What's this guy called? This guy on the bottom, this acid here. What's this called? Right, well, let's have a look. It's 1, 2, 3 carbons in a row, so it is propanoic acid. Propanoic acid. Now, something's on my propanoic acid, isn't it? There's an OH on my propanoic acid. There it is. And it's at number 2. So this is called 2-hydroxypropanoic acid. All right. I hope that makes sense. If it doesn't, give me a shout and I'll clear any confusion. All right. Bye-bye.